Bien, bonsoir. Mesdames, Messieurs, merci d'avoir rejoint le Théâtre du Manège à Mons pour cette dernière journée de la Big Data Week qui est une première en fait en Wallonie et particulièrement à Mons. Je suis très très heureux en tant que président du Mondanéum de vous accueillir aujourd'hui. C'est un jour un peu spécial pour le Mondanéum, je vous en parlerai dans la fin de ma très courte intervention. Mais je voulais souligner le fait que le Mondanéum a pris un rôle important finalement dans l'organisation de cette Big Data Week et que nous sommes finalement en bonne compagnie puisque c'est une activité qui est organisée depuis Londres et depuis quelques années, 3 ans je pense, et dans laquelle des villes comme Barcelone, Berlin, Chicago, Dubaï, Istanbul, Kuala Lumpur, Sao Paulo sont partie prenante. Et donc la Wallonie dans son ensemble, et Mons en particulier aujourd'hui, nous sommes effectivement en bonne compagnie. Alors le Mondanéum se réjouit évidemment du succès de cette première édition, mais vous savez qu'on ne travaille jamais seul, nulle part, et encore moins lorsqu'il s'agit de donner un éclairage particulier sur ce qu'il est convenu peut-être d'appeler, c'est peut-être un peu daté déjà, les nouvelles technologies. Mais il faut vraiment remercier Google du soutien qu'il apporte dans cette organisation, ainsi que toute une série d'amis et de partenaires comme Futurocité, qui a cet après-midi, je pense, aussi animé l'après-midi, IBM, Mobistar, Technocité, Connexion, BHC, le CETIC, l'Université de Mons, bien entendu. Je vais en oublier. L'Université de Namur, avec le réseau européen No Escape, Transculture, la Fondation Mons 2015, l'Agence Wallonne des télécommunications, Data News et Régional IT. Et donc, je l'ai dit, Google a joué un rôle et joue un rôle important à la fois dans l'organisation de ces conférences et dans les relations avec le Mondanéum. Voilà, ça va mieux comme ça ? Ouais. Et je remercie Bill Kingston qu'on va accueillir dans quelques instants, qui vraiment est la personne de contact et qui est devenu un ami du Mondanéum et de Mons même. Voilà, pour cette grande conférence de ce soir qui nous accueille au Théâtre du Manège, bien entendu. L'AOT, je ne l'avais pas encore cité, qui retransmet en streaming et en live sur le web. Alors, je vous disais que c'était un jour un peu particulier pour le Mondanéum. Ce matin, nous étions avec toute l'équipe à Leuven, dans la bibliothèque universitaire, puisque, figurez-vous, le Mondanéum et particulièrement le RBU, la classification décimale universelle inventée en quelque sorte aussi par Paul Hotelet, et la réserve précieuse de la bibliothèque de Leuven, de l'université de Louvain, a été reconnue par l'UNESCO dans un département qui s'appelle Mémoire du monde. Et donc, oui, merci. Merci pour l'équipe surtout. Vous savez qu'il y a une équipe extrêmement dynamique et qui a fait en très peu d'années, en une quinzaine d'années, a permis de redécouvrir le Mondanéum et de le mener jusqu'à l'UNESCO. Je crois que vous avez eu raison de les applaudir, bien entendu. Voilà, je ne serai pas plus long. Bill Kingston, qui est notre relais, mais qui est bien plus que ça d'ailleurs. Salut Bill.
Salut. Ça va?
Et Kenneth, tu nous amènes Kenneth Cuckier aujourd'hui, donc je vais te laisser
le présenter un peu
mais
la
je t'en
philosophie.
remercie vivement en tout cas.
Merci
à vous,
beaucoup.
bonne soirée.
Merci. Donc, merci Jean-Paul. Donc, je voulais dire juste quelques mots pourquoi Google est ici, pourquoi on soutient et pourquoi on vous amène Ken. Donc, personnellement, ça fait 2 ans depuis que j'ai commencé à travailler. Jean-Paul, on a dépassé l'anniversaire de 2 ans. Je crois parce que c'était avril 2013 que Google et le Mondanéum avaient fait un partenariat. Nous avons un de nos grands centres de data juste à côté de chez vous et C'est difficile d'y aller pour les raisons de sécurité, etc. Donc, on a décidé d'amener le centre de data ici à Mons pour essayer de l'expliquer un peu ce qui se passe dans la région et pourquoi c'est important. Et le Mondeneum, on avait ce lien qui était incroyable, du Google de papier, il y a 100 ans, fait ici en Belgique, avec la même philosophie de faire l'information accessible. Donc, c'était un partenariat sur le data center, c'était un partenariat philosophique, et ensemble, on a dit, qu'est-ce qu'on peut faire pour Mons 2015, qu'est-ce qu'on peut faire ensemble, et pour nous, la réponse était de faire quelque chose qui avait du sens, d'amener des hommes qui parlera à vous, qui expliquera ces nouveaux défis de la nouvelle technologie. En octobre, Vint Cerf, un des pères de l'Internet, est venu ici. On avait un grand événement pour expliquer les racines de l'Internet et l'avenir. Il avait amené les Google Glass aussi. Et on veut continuer dans cette démarche d'amener des gens qui peuvent en expliquer ce qui est l'Internet et les possibilités, les défis de l'Internet. Donc, pourquoi Ken? Je connais Ken depuis 20 ans maintenant, donc encore plus loin que Jean-Paul et Delphine et le Mondeneum. On a travaillé ensemble à Libération à Paris, quand on était des jeunes journalistes ensemble. Et on est resté en contact et il y a 2 ans, juste après qu'on a commencé ici, j'ai revu Ken à Salzburg pour l'Institut de Salzburg et j'ai donné une conférence sur la liberté dans l'Internet et Ben est suivi avec une conférence sur le big data, sur tous les défis. Il me racontait qu'il était en train d'écrire un livre là-dessus et il écrivait beaucoup pour The Economist. Il est employé de l'Economist, éditeur, rédacteur de The Economist. Et j'ai écouté, j'ai trouvé ça vraiment merveilleux. Donc, on a pensé, quand Delphine cherchait les interlocuteurs pour ce soirée, que Ken sera l'homme parfait. Donc, il va vous parler pendant, je crois, une petite heure. Il a une présentation, mais on reste ouvert à vos questions. On va revenir et prendre les questions. Il aimera bien écouter vos idées, etc. Et il comprend le français. Il va parler en anglais, mais il comprend le français. Donc, faites attention. Ken.
Good. Thanks a lot. I do understand French. Je parle un petit peu de français, donc comme ça, je suis très content que Bill n'ait pas donné toutes les histoires de notre vie jeunesse des journalistes à Paris, parce que comme ça va être peut-être trop osé à dire. Alors, je vais arrêter de parler français parce que je pense que je risque de casser vos oreilles et je passe en English. Big data. Big data is a big topic. We're hearing a lot of it in the press. You can't open up a newspaper without seeing it and the name. What is it? Why is it important? What does it mean? What is big data and why does it matter? To start, why don't we pose a few questions and think about what it could possibly be? So my first question is this: if you had to track economic growth, but without measuring money, what would you do? Second question: if you had to uncover drug side effects, but you couldn't perform a medical study, how would you do it? Third question: if you had to know when is the right moment to buy a plane ticket, because you knew whether the price was going to go up or go down and you're on an online travel site, how would you know when to buy that ticket? Well, that one's a little bit easier. That one's a story, and the story is of a company, and the company is called FairCast. A few years ago, a computer science professor in the United States had to travel to his brother's wedding. He lived in Seattle, and his brother lived in LA. And so he did what we all know to do, which is he went online long before the date of the departure, and he bought his ticket early, because we know that if you buy the ticket early, you save money. So, Very simple. Day of departure comes. He goes onto the airplane, and as the plane is taking off, the devil gets the better of him. And he asks the person sitting next to him, how much did he pay for the flight? Only to learn that the person paid much less and had bought the ticket only a few days before. The computer science professor, Ornezioni, is very upset. He asks the next person, same thing. The next person, same sort of story. In fact, there's a small little buzz going on in the back of the airplane as everyone is comparing notes on how much they paid. It's kind of interesting because we all know when we're in the back of the airplane in economy class that it's a pure commodity. Every one seat is just like another seat. There's no differentiation between them. But we all also know that everyone paid a different price. And we don't know why that is. What is the formula for airline madness? So Ornezioni is a bit perturbed because he realizes that he has paid a lot more money even though he bought the ticket longer in advance than most of the other people. The difference between computer scientists and ordinary people is that when we put our tray table up in the upright position and put our chairs up, and then when we leave the gate of the airplane, we leave our troubles behind and we get on with our life. Computer science professors that don't. They sketch out methodologies on napkins that they're given by the stewardesses, and he creates a little project. What the project is going to do is a souped-up version of what he has already done in the back of the airplane. And specifically, what it's going to do is it's going to scrape some data from the internet, and it's going to make a prediction. And it's going to predict whether a given price that you see online is likely to, for a given route from one city to another, is likely to go up or is likely to go down. He does this. He calls the research project Hamlet. To buy or not to buy? That is the question. Okay. So he gets some venture capital money, and the company FairCast is born, and now it's making predictions. It's basically telling people whether a given price is to go up and to go down. Saving customers lots of money. It's empowering them because they can make wiser decisions when they're going on to online travel sites. He realizes it's not just simply for online travel. It applies to anything that has huge price variability, a commodity product, and lots of data to learn from. Here's the nub. By 2009, he's crunching 200 billion flight price records with which to score his predictions that represent almost every single seat on every single plane for every single route for all of American commercial aviation for an entire year. This is something that was pretty much unthinkable to do a decade earlier, and now it was being done by a startup. Microsoft knocks on the door, thinks the technology is very interesting, likes the business, decides to buy it for $110 million. But here's the sting in the tail. You just know that when the airlines created electronic passenger records in the 1960s, never for a second did they think that their own information could be used against them to undercut their own business model. So what's happening? What's going on here? Well, part of the story is a technology story. We can do things that we never could before. Another part of the story is the data. We have the data where we didn't have the data in the past. And a third part of it is about the mindset. Ornezioni had a big data mindset. He understood that the data could tell you something. You could learn from it if you had the technical competence and the humility and the wisdom to listen to it. That there was value in the data, latent value that could be unearthed to create new forms of economic value in terms of new products and new services. The data had become an asset. It was a resource. It was a new raw material of business, a vital economic input. Traditionally in economics, we have thought of the three factors of production: land, labor, and capital. And we can understand why the classical economists didn't add information or data to that. At the time, it was immensely hard to capture information, to collect it, to store it, and to process it. It turns out that when I was writing the book Big Data, I had this presumption that the world of the classical economists in the late 1700s and the early 1800s was riddled with this sort of prose-laden economy in which, the economists weren't even called economists at the time because they didn't have math, really. What they were called were essentially social philosophers, political philosophers. Adam Smith, notably, taught philosophy. You would think that their vision of the economy was based on words and how they could describe things. It's just not true. I had to reread The Wealth of Nations. Okay, because my economics professor isn't here right now, I had to read The Wealth of Nations for the first time to learn, to actually see that you get into like chapter 40, and you've got page after page of wheat yield, right, and industrial production. Right? It was very data-driven, but the fact is, you had to record data on parchments with a quill pen in an inkwell. It's just impossible to do. Right? The difference today is that it costs next to nothing to collect information, to process it, to store it, and to analyze it. So what is big data? How would we describe it? What does it mean? Well, it meant something once. Okay? Okay, sorry, I wasn't certain if it was me. Okay, when you're a speaker, you always presume it's you. Okay, so what is big data? Okay, well, about a decade ago, the term cropped up because there was no other good term to use. What was happening was that in certain domains, in biotechnology, where they were sequencing the human genome, in astrophysics, where they were collecting more information than ever before, these researchers, often in America mainly, were being swamped by the amount of information that was just coming at them. And the reason why is that digital information grows exponentially. And when it grows, you're just getting so much more information. Every 2 years, it essentially doubles. So suddenly, unless you're on that same cycle, 2 years later, you're getting twice as much. And it's just overwhelming them. And there was no good way to describe what was happening. The amount of information had actually surpassed the technical limitations of both the software and the hardware they were using to process it. So the analysts themselves had to innovate at the layer of the infrastructure in order to make it work. Right? There was no good term to describe the fact that they were doing something fundamentally different today than they were doing in the past. They were talking about computational science, for example. The term big data was one of the terms that was out in the air, and it seemed to stick. Okay, the next reason why the term was sort of embraced by Silicon Valley and then beyond was because a strange little technique called machine learning, that is a branch of artificial intelligence, which itself is a branch of computer science. It worked a little bit up until then, but it didn't work very well. But suddenly, when they were adding more data to the problems that they were putting it towards, not, for example, adding more processors or adding smarter algorithms, but just simply adding more data, these techniques actually started to work extremely well. And so this idea of big data was born. Now, today, when you read it in the headlines of the newspapers, they're not really talking about what's going on in biotechnology, and they're not really talking about what's going on in this strange branch of computer science called machine learning, that I'll talk about more later. What they're really talking about is applying basic statistics and quantification to areas of life that have never really had this sort of statistical veneer before. And I think that's fine. I don't want to be very orthodox about how we think it, or purist about how we think about big data. However, that was the origin, and now it's been, if you will, changed, it's been diluted, and that's fine too. What we are finding, though, is that big data is not just simply about the size of data, although the term big is in it. It's more than that. Sometimes it's about the speed of the data. It's the variety of the data. However, the size isn't a bad place to start, because the size that we're dealing with is huge, larger than ever before. And what we find with big data is that you can do things with a large body of data that you never could do when you were only working with smaller amounts. That a change in scale leads to a change in state. That a quantitative shift leads to a qualitative shift. Or if you like, more isn't just more is different. Okay. So what does more look like? Well, more looks like this. Okay. As you can see, there's a lot of information. Most of it is digital. The bottom part, which is purple, is digital. The top part, which is mauve, is analog. And up until the year 2000, we liked to think back then that we were living in the information society, but we were doing so in name only. Even back then, the amount of analog information in the world, things like library books, paintings on the walls of museums, Post-it notes, vinyl LP records, that's grossly subsumed the amount of digital information in the world. But because analog information grows at a linear rate and digital information grows at an exponential rate, the amount of analog information is still growing. We've never produced more paper than ever before. However, the amount of digital information is just growing vastly larger. And by 2002, there was parity. By 2007, which this data is from, you can see it's about 95% to 5%. But the amount of digital information doubles roughly every 2 or 3 years. So by 2010, this purple portion would be twice as large, basically almost down to the bottom of the screen. The little mauve portion at the very top, half as large. By 2013, right, be twice as large again. So now we're going to the bottom of the stage, and we're getting a very small sliver of analog information. And these trends seem to be continuing. It doesn't look like anything is going to stop that. Let's take an example of what this means in sort of everyday life, okay? When the Human Genome Project was completed for the first time, in which they sequenced the first human genome, they did it in 2003, in April of 2003. It took them about 10 years to do, and it cost them roughly $1 billion to do it. Today, a single laboratory can sequence a human genome, all 3 billion base pairs, in a day for about $1,000. Think about that. Data like this always gets said at conferences and just kind of swooshes past us. So let's just do this. Let's just stop and think about what that means for a second. Then, 10 years, $1 billion. Now, one day, $1,000. So the first thing it tells us is that the era of personalized medicine is just right before us, in which we are going to be tailoring drug therapies to who we specifically are, our own genetic makeup, not this sort of average man to which it's a fiction because no one truly applies. That's the first thing. The second thing is that the trends that are happening in biotechnology might be in extreme form, but it's happening everywhere else. Every domain is being swamped with more and more information. It doesn't matter if you're in retailing, if you're in advertising, if you're in media, if you're in manufacturing, you're dealing with more data than ever before. And you can do new things with it if you're careful. So there's many techniques and technologies that are related to big data, linear correlations and other things that are very arcane. But there's one that I want to talk about today, and it's the technique called machine learning, what I was referring to earlier. So let me first ask, does anyone here know what machine learning is? Have you heard about it? Okay, well, so Bill doesn't count. He works at Google. Google is a pioneer in machine learning. Okay. But there's a couple hands. Let me talk about machine learning because I think it's going to be such an important feature of society going forward. So its origin came from Arthur Samuels, and he's the fellow behind me right now. He was a computer developer in the 1950s and 60s at IBM, and he liked to play checkers, which the British called drafts. Okay. And so he wrote a computer program, right, a very early version of a computer program, to play checkers. So he could play the machine against checkers, but you can maybe guess what happened. He writes a computer program, teaches the computer how to play checkers, and he plays the machine. And he wins. And he plays the machine. He wins! He plays the machine, and he wins. Why? Because the machine knows what a legal move is. Arthur Samuels knows something else. Arthur Samuels knows strategy. So he writes a small little subprogram alongside it so that at every board configuration, the computer calculates the probability that a given board after a move will likely lead to a winning board versus a losing board. Arthur Samuel plays the machine, wins, plays the machine, he wins, plays the machine, he wins. And then he leaves the machine to play itself. It plays itself, it collects more data. It collects more data, it increases the accuracy of its predictions. And then he returns to the machine, and he loses. And he returns to the machine, and he loses, and he plays the machine, and he loses. And now Arthur Samuels, a human being, has taught a machine to exceed his own capacity in the game that he taught it. Arthur Samuels knows strategy. The machine doesn't. It's just probability. And this technique of machine learning is now finally going to go everywhere, not because it didn't work before, but because we now have more data. Why do you think there are self-driving cars? Have we gotten any better at enshrining all the rules of the road into software code? No. Because software is better? No. Because processors are faster? No. Because they're cheaper? No. Algorithms better? No. All of those things are true, but the reason why we have self-driving cars is because we changed the nature of the problem from one of trying to explicitly teach a car how to drive to one in which we collect lots of data, more data than we ever could before, and we tell the car, you figure it out, you infer, you decide, you make the prediction, thousands of predictions a second, that this is a traffic light, that this traffic light is red and not green, that the appropriate thing to do now is to accelerate versus deaccelerate. Okay? Voice recognition works. Why? Because we have data, because we've datified the words. Computer translation works very well now where it didn't in the past, because we've added more data to the problem. We've turned it into a machine learning problem, rather than trying to explicitly explain to the machine why you would use one word in one context versus words in another. We just pour in lots of translations. Right? And what we learn is that the computer knows not to determine what the word is relative to the best substitute for another word, but to look at the word in context of the other words and score a prediction, the probability that one word is a suitable substitute for the other word. And when you have vastly more training data to learn from, more translations, you increase the accuracy of the prediction and suddenly things work. This technique has also been used in research for trying to diagnose severe cancer. When you take a pathologist, a human being, and you say, hey, look at these slides and try to determine if there's cancer here or not, severe cancer or not, they do it at a certain level of accuracy, right? And you take a machine, you try to teach it what to do. You say, here are the traits that you look for. You do it. It turns out, one does better than the other. The human beings do better than the machine. Why? Probably because not everything that you know with which you make your decision can be easily communicated. There's lots of things that an experienced pathologist will will look for and have a sense of judgment about that they won't be able to actually articulate very well. It's called latent knowledge, right? We all have that in whatever domain that we're in. We consider it a second sense, a sixth sense, but there's knowledge there, and often it comes from experience. Fine. So what if we change the nature of the problem? What if we were to take all of the biopsies, same thing that we want to look at, and we now tell the machine not what to look for, but we simply tell them if the patient lived or died and how long after from the time that biopsy was taken, in which the machine has to infer both that the person probably died because of the disease, and secondly, what is interesting, what are the patterns in this biopsy, in this sample, that are different than the others that best predict the disease. And sure enough, when we do that, the machine finds the 11 telltale traits that best predict severe cancer. The human pathologists only knew of 8 of them. 3 of these signs, 3 of these traits were ones that the human beings never knew to look for. Spooky. The machine saw it in the patterns. We hadn't. Behind big data are 3 features. Okay. More, messy, and correlations. Although there's no single definition of big data, and that's a good thing, because to define something is to constrain it, these key features are ones going forward that are going to almost be ones that are kind of characteristic of big data. So more is sort of what you would think. Okay? We have more data than ever before, and because we have more data, we can do new things. But what's interesting is we've always had more data. What we really have is more data relative to the phenomenon that we are studying. Okay? And in some instances, we have something we'll call n equals all the information around a given topic. We don't have to rely on samples as much anymore. We can go for all the data and study that and then see something in its totality. By doing so, because sampling works very well in certain cases, but often in cases where we want to ask very blunt questions, right? We can ask much more refined questions and granular questions and see details that sampling doesn't assess when we're dealing with all the data at hand. Secondly, the data can be messy. For years, the great, exaltation of science has been that we have had highly curated and clean data sets, and we can understand why. Because when you're only collecting a small amount of data because it's so expensive to do, you have to be very sure that the data you do bother to collect is as clean as possible, because any error at the level of the measurement is going to lead to huge errors at the level when you extrapolate to the whole. Okay? But with big data, when you're dealing with not just maybe 15% more, 100% more, but you're dealing with orders and orders of magnitude more data, you can give up, or at least on your great preference for clean data, or you can tolerate some messiness. Now, of course, that's not to say that you would prefer messy data to clean data. Of course, you'd rather have data that was better, either more precise or more exact. Right? At the same time, the data can't be outrightly wrong. That would just be nonsensical. But the idea is that when you're dealing with vastly more data, you win on the trade-off. You can still learn from it, learn more and better than you could with small data sets, even if there's some messiness in that data. So we need to embrace the messiness and to live with it. And the third feature is correlations. It's the idea that we've often tried to understand the world through a series of causes and effects, causality. And in some ways, the great beauty of science in the 1800s was this quest for certitude to find the causes behind all things. Right? But when you're dealing with myriads of variables, and the data is being ever-changing, it's coming in quickly, and you have a machine learning algorithm that is doing the calculations and the weightings, not a human being, you're not always able to find the causality. Always nice to have causality if you can get it. It's just very expensive, and often we know in the history of science and medicine is that when we think we have it, we really don't. The world's a complex place. You can't know everything. However, if you have the correlation, what we find is that in many instances, that's just good enough. It helps us in the here and now when we want to act. Let me give an example of what I mean by that. Premature babies, they're known as preemies in the trade. So the problem with premature babies is that they're extremely prone to infection. So it's extremely important that we identify if a patient is going into an infectious state so we can treat it as soon as possible. But you just know that if you were to go to a hospital right now, they're going to attach tubes and wires to you. They're going to collect information, but you also know they're not going to save it. They're not going to reuse it. They're not going to aggregate it. They're not going to store it. They're not going to reanalyze it. And I sort of think that today, in 2014, our medical practices are actually barbaric. They're actually almost akin to bloodletting, because one of the most valuable aspects of patient care, the data associated with what works, with whom, under what condition, just simply gets thrown out at the end of the treatment like a bloody bandage. And people are going to look back on this period and think that it was ludicrous that we mishandled some of the most valuable aspects of the experience of treating a patient that we could learn from to treat future patients. Be it as it may, we will get there. I have a lot of sympathy for medical practitioners. 10 years ago, you actually couldn't save the data, store it, and reanalyze it. Today you can, in the same way that if you wanted to measure every single price flight record of every single flight in the United States 10 years ago, it would be difficult to do, and today you can do that. So things have changed. Medical science will catch up. Research is happening in Canada, in which they are taking the data associated with premature babies and trying to look for trends. What they're doing is they're capturing 16 real-time flows of health information, things like vital signs, EKG, blood respiration, blood oxygen level, temperature, and finding patterns in that data. And when they do, it's over 1,000 data points a second. When they do, what they're finding is things that would surprise us, right? What they find is that the best telltale sign that a baby is going to have an infection is not that the vitals start to go haywire. It's that they start to stabilize. And you can just imagine generations of doctors in the past looking at a clipboard beside a crib, seeing that the vitals are getting easy and going calm, and says, things are settling down, I'm going home for the night, give me a call if there's a problem, only to be woken up at midnight that a tragedy is underway. Now, we don't know why, right? We don't know the biological mechanism in place. But what we do know is that by seeing and analyzing the data, we can spot the signs of infection early in time for us to act. Behind this is more Messian correlations. Think about it. We have more data than ever before. We're just collecting more because we can, right? Secondly, the data's messy. It's always being sensors always being tossed off the child as it turns, right? It's not as accurate, as pristine as we would like. And it's simply a correlation, right? We don't know why things are happening, we just know what they're happening. But in many instances, knowing what, not why, is good enough. The correlation, not the cause and effect. So what's happening when we think about how we might treat disease is already happening when we think about how we can actually maintain something a little bit more simple than the human body, and that is vehicles, right? Cars. UPS has 70,000 trucks on the road in North America, and each one is fitted with sensors and telemetry, so you know where the vehicle is, but you also can monitor things. Now, we know when there's a breakdown of a car, things don't fail all at once. We know as drivers that they sort of tell us, they whisper to us that something's going wrong. And we know that because as we're driving, something doesn't sound quite right or it feels funny, right? So if we put a sensor into the engine, or lots of sensors, we'd be able to identify, if we have 70,000 vehicles, what is normalcy, right? What does a normal engine look like and sound like? What is its vibration like? What kind of heat is in what range? And when something leaves the normal range and there's an abnormal behavior, we can identify that a part is about to fail, and maybe it's in a known parameter that we know what part is about to fail. At any rate, we know that we can actually turn it into a service station and replace the part before it breaks down by the side of the road, right? And this is a way that UPS saves millions of dollars a year by replacing parts when they need to be replaced, not simply on a regular scheduled maintenance cycle, and certainly not before they've already broken and you have to actually replace the van and take all of the packages out of it and put it into a new one. Now, one reason why we have so much data in the world today is because we are collecting things that we've always collected information on. But another reason why we have so much data is we're taking things that have always been informational and we're rendering it into a data format. We are datafying it, so to speak. Okay, so think about location, right? Where are you? Where am I? You know, where is Paul Otelet? Okay, is Paul Otelet in his office, or is Paul Otelet strolling in Belgium? Where Paul Otelet is a matter of information, but it's not a matter of data. Okay? However, I think all of us probably have cell phones, maybe they're smartphones, they might have GPS. You know that there is a spreadsheet somewhere that has your location at every moment of the day for years in that spreadsheet somewhere. Location has become a matter of data. It's been datafied. Okay? So we've solved that one. Location is a matter of data. You can think about it in terms of words, right? We could read articles, but what if we were a drug company and wanted to look for promising compounds and drug targets? What we might want to do is take a look at all of the medical journals associated with a given drug or a given disease going back 150 years and look for patterns and correlations. What we might find is that there's things that have been popping up in footnotes or that were never part of the formal study but were findings nonetheless that are interesting, that are reoccurring. But a human being, if they were to try to read 150 years of a scientific journal, they wouldn't spot, or it would just be by luck that they would cotton onto because they're buried at the back of the paper. Right? But in fact, the computer can spot and can come up with a list saying, oh, if you're studying this, look at these other promising targets as well, and this is how new drugs are being discovered, and in material sciences, new materials are being discovered. Okay? You can think about it in terms of posture, the way that you're all sleeping right now, okay? The way that you're all sitting right now. Okay, okay. So everyone sits slightly differently, right? Bill is sitting differently than Delphine, right? And it's a function of your leg length and the way that your back is contours of your back and your distribution of your weight. And you know that if I were to put sensors, maybe 100 sensors into the chair of where you're all sitting right now, I could create an index that's fairly unique to you, right? It's like a fingerprint, but it's not your finger. Okay, so what could I do with this? All right, researchers in Tokyo are using this technique as a potential anti-theft device in cars. The idea is that a carjacker jumps behind the wheel, streams off with the car, and the car recognizes that a non-approved driver is at the wheel. Maybe the engine conks off unless he types in a code, a password into the dashboard. Okay? If you are the parent of a teenager, maybe you can think of other uses of this technology. Right? You tell your child you're not allowed to take the car out after 10 o'clock. That's it, right? Can't do it. Okay. Now, what if every single car in Europe, every car, had this technology in it? What could we do with it then? Well, maybe what we'd be able to do if we aggregated and analyzed it, maybe we'd be able to spot the telltale signs that best predict that a car crash is about to happen in the next 5 seconds. And then what we will have datafied is driver fatigue. And the service would be when the car senses or detects that a person has slumped into this position, that it alerts the driver. Maybe it honks inside the car, or it vibrates the steering wheel to say, hey, wake up, pay more attention to the road. Right? These are the sorts of things that we can do when we datafy more aspects of our living. Right? Datification serves as a lens into the value of social media networks. Twitter datifies our stray thoughts. Facebook datifies our friendships. LinkedIn datifies our professional contacts. IBM has a patent on floors, on a floor covering that is a little bit like a smartphone screen. It can identify when someone goes into the room or leaves it. Maybe someday it'll be able to identify, based on the way the person walks and how they stand, who is in the room. But what is certain today is it can identify if someone standing in a room falls and doesn't get up. A very useful application in an aging society. Our smartphones are not that smart. We have to use a password, to enter it so that we can do it. But surely it has so many sensors in it, it should know who we are just by the way we walk, by our gait, for so to speak, right? By how we lift it up to our hands. Right? We will get there, but we're not there yet, right? And Apple has a patent on earbuds that actually can collect our vital signs. So there's a great project underway in which we datafy more aspects of living. By doing so, we're able to store it, we're able to share it, able to process the data and use it to extract new value. So what is the value of data? Well, in the past, the value of data had been the primary purpose for which it had been collected. But in the world of big data, it's all of the reuses with which we can put the data. So let's take the example of Walmart. Like all retailers, it collects information about sales transactions. Okay? It does that for bookkeeping to know how much it's selling, how much it's earned. What else can it do with its data? Well, years ago, it went through its great database of past sales transactions and married it with weather data from the United States, and it was able to find some surprising correlations. It found that whenever there was a storm about to hit the northeast of the United States, not only would sales of storm supplies like flashlights and batteries increase, but also sales of Pop-Tarts, a sugary American breakfast treat. I don't say food, but I say treat. Okay. Now, we don't know why this is the case, but you can imagine that when Walmart discovered this correlation, they knew just what to do, that you would take the Pop-Tarts and you would stock it in front of the shop, next to the flashlights and next to the batteries and next to the rope, to ease life for consumers who are rushing in and rushing back home before a storm hits, and also to increase its sales. Okay. The value of the data is in the reuse of the data. In this respect, the data has become a corporate asset. Okay. So if you had to track economic growth, but you couldn't measure money, what would you do? Traffic. A company called INRIX does traffic predictions for satellite navigation systems. It doesn't just tell you what is the quickest route to get somewhere because of the road network. It tells you what the quickest route to get somewhere is because of the traffic in its vicinity. Very useful. Very good. Each car is like a beacon. They have over 100 million vehicles registered. So if you're buying a Toyota or you're buying a BMW, they're probably using INRIX's satellite navigation system with which to make that prediction for its traffic. But it's not just receiving information down. The uplink is it's actually giving the traffic information back to INRIX so that it can increase the accuracy of its prediction. And what they have found is that if they look at traffic in metropolitan areas at rush hour, it's an extremely good proxy as a leading economic indicator for GDP growth, for economic growth in those areas. Okay. Big data challenges what we know and how we know it. Think about it as something as fundamental as education. Education. We have been educating people for thousands of years. Plato's Academy, right? And of course, the great project of public education in Europe in the 1800s. Okay. But education radically changes when we add a data aspect to it. Think about how it could happen. So we have textbooks today that we read, and students read it at different rates. And there could be pop quizzes that come up as you're reading to see if you're reading too slow. It might remind you to read a little bit quicker, or just to see if you understand the material if you're reading slow because you're bored because you know all of it. All of this could happen when you're reading it on an e-reader, like an iPad or a Kindle. The data of how you read, everything you click, how you answer, when you answer it, whether you take a long time to to go through a mathematical question, or whether you can get the answer in a sudden burst of insight, can be found by measuring every activity. Right? The great appeal of something called MOOCs, these massively open online courses, are that they're collecting data. One computer scientist I know who is actually teaching one of these classes was able to identify through the data that many students who were going through the course would go through the course and get to about the 30th lesson and then go back to lesson 8. And when you're teaching 10,000 people, or 100, actually it was about 100,000 people, right? And 20,000 people are doing that on their own. You can say, something's going on here that I need to know about. And sure enough, he goes back and he finds out that that course was a math refresher. So he realized that many people going into his class were getting deeper and deeper into the coursework, but weren't confident in their math skills. So he could retailor the class to make sure that he could keep those people in it so that they could actually boost the math skills and review it earlier on. So that teaching, the act of teaching, improves when the textbook talks back to the teacher, right? Learning improves when the textbook, through a machine learning algorithm, right, through big data, can identify what sort of learning works best with what sort of student. Say, oh yeah, you know integers really well, we're going to put you onto something more advanced, or you need to go more slowly, and you need to take more time to master skills. You're going to get the same grade as the other kid, but it just takes a longer time for you to really drill down on it. And the electronic textbook, am I going to help you drill down on that? And we're going to discover something new that we didn't know about learning styles and learning behaviors, right? Already, I'm very impassioned about this because I've got a 6-year-old and a 3-year-old. But why we should all be impassioned in it is because we've all gone through the educational process, right? And we all know people who have been victims of educational testing in which they just had a poor day, did poor on a test, and they were just seen as someone who wasn't good at math, and they were pushed off to the side, right? Now we don't have to do that. We can monitor progress all throughout, and when we do that, we're having huge findings. One of the findings is that people learn at different rates, and by learning that, we've found that actually we can take students who, when they start a course and grade really low, as they get better throughout the course, they start doing better than the people who did very well at the outset, who we thought were math whizzes, but they weren't math whizzes. They just did well on that test that one day. And it's actually going to be very liberating as we educate people better through using big data. Where does this take us? There are critics to big data, and it's important to understand them. I'm going to just superficially explain what the criticism is. In short, the criticism is when you have more data, you have more noise. That is to say, you have spurious correlations. You find something that you think is a finding when in fact it really isn't. It just happened by chance. And the poster child, if you will, the best example that the critics reach for is Google Flu Trends, right? Google Flu Trends was a system that Google designed about 4 or 5 years ago, in which it could identify the location of an outbreak of the flu in the United States using search queries alone. It didn't have to know, it didn't predict, right, what those search queries were, and then try to see if it correlated. It didn't want to do that. It took 50 million search queries, right, that are commonly occurring. And then it ran mathematical models, about 500 million mathematical models against them, to see if they best matched the public healthcare data from the Centers for Disease Control, and they were able to identify the 45 terms that all related somehow to flu, luckily, it didn't relate to things that are outside of the flu, that best predicted that outbreak was going to take place in that area. It worked very well, but then it stopped working so well. And in fact, by 2011, 2012, and 2013, it was actually overestimating the flu quite considerably, and people have criticized it. But the criticisms actually are not as well founded as you would think. So the first problem is that people want exactitude and certitude, but hey, that's like an 18th century notion of how the world works. The world is more probabilistic than we think. It's hard to find certainty, right? And we know this as individuals when we hear a weather forecast, right? The weatherman never says it's going to rain tomorrow. Well, judging on the weather of Mons, the weather forecaster probably did say it's going to rain today, but leaving that aside, they say there's a 90% likelihood of rain. And if you carry your umbrella out of the house and it's sunny all day long, you don't say the guy got it wrong, because within his prediction, embedded in it, was the possibility that it was going to be sunny. Right? So too, Google flu predictions was wrong, but it was wrong within the margin that we know that it could be wrong. And it called the direction correctly. If you will, it may have said that there was going to be thunder showers when there was only a sprinkle. Okay, that's the first. The second one is, what is ground truth? What does truth mean in this environment, right? Because we presume that Google flu trends, searches for the flu, are only a proxy of people who have the flu, and that reported data of people who have actually gone to the public health care authorities represents those with the flu. But you know what? That's not true. It's true that Google flu trends are people who are searching for the flu. They may be doing it because they're ill, but they may be doing it because they hear sniffles by someone else who's sneezing in the workplace. That's right. Well, this is data from the United States, right? In the middle of the financial crisis, 2009, 2010, 2011, where people might not feel comfortable taking an entire day off of work to go to a clinic because they have the sniffles, they're just going to power through it. Or they may have lost their jobs, and because we don't have national health care in the United States, or we're just getting it right now, that they may not feel that it's worth their while. They may have lost their health care coverage, and they don't want to pay a private clinic, so they actually don't go to the hospital. This is to say that even the data that we presume to be what it represented, cases of the flu, might not be. So it's not certain what is ground truth, and in fact, Google might have been more accurate than the healthcare authorities, the Centers for Disease Control's data itself. Just might have been. And the third thing is this, that the researchers themselves had, even in their own paper, when they were criticizing Google flu trends, noted that the blended model, combining Google flu trends and their own reported data from the CDC, was actually better, and worked best. And what they say is this: does this mean that the current version of Google flu trends, big data, is not useful? No. Greater value can be obtained by combining Google flu trends with other healthcare data from the Centers for Disease Control to show that there's a benefit to it. Big data is leading to new forms of rivalries, right? Stuttgart has a burning interest in the future of personal transportation. So why did the first self-driving car come from a search engine in California? Well, one industry perceived its business as bashing metal, another of processing bits. And if you had to determine if there was an adverse drug reaction based on search queries alone, adverse drug interaction, but you couldn't perform a medical study, what would you do? The answer is in the slide. Bing. You would look at search queries. Specifically, in this research from 2 years ago, you would look for searches for a known drug that lowered cholesterol, another known drug that was an antidepressant, and for symptoms, searches for symptoms of a known disease. In this case, it was hyperglycemia. You look for the prevalence of one of the symptoms and one drug, symptoms and the other drug, and then for both drugs in unison, the area A in this Venn diagram, and sure enough, you would have struck gold. When the researchers did that, they found that symptoms were at the bottom line. The second line there is searches for one drug. Second line is searches for, but the red line at the very top is searches for both drugs in unison. More than twice as likely. If you're searching for those symptoms, it means you're more than twice as likely to be looking for both drugs, not just one or the other. Now, what that tells us, it's not a smoking gun. It doesn't say, hey, there's a problem here. Well, actually, it does say there's a problem here. It doesn't say, you must, close down this drug, right, and put the CEOs in jail. But it does tell us that we need further research. The critical aspect to this, though, is that this information is not on the drug label because it wasn't part of the medical study. So if you're a patient, you really got to know this information. If you're a doctor, you want to know this information. If you're a health insurance company, you got to know this information. If you're a regulator, you've got to know. If you're Microsoft, maybe you should start licensing this information out to these other industries as a revenue source. In this world, access to data is the most critical thing. Now, to be sure, we can have too much access to data. Let me conclude with some of the problems that the world of big data are going to bring. So the first one in the risks are privacy. It has been a problem in a small data world. It is going to be a big problem in the big data world. It might not be a necessarily different problem, but it's going to be a problem at a larger scale. The next is propensity, and it's the idea that there will be algorithms that are likely to predict what we are going to do before we've actually acted, and we may be penalized by our propensity to do things. It's a little bit like the world of Minority Report and pre-crime, in which we can identify that someone is likely to commit a crime. What does society do? Right? If I can tell you with 95% accuracy that this person over here is going to be a shoplifter, if I don't intervene, I'm being anti-science, and if I do, I'm taking away his free will. So maybe in a big data world, we're going to have a conversation and enshrine the principle of human volition and human agency as something sacrosanct and worth preserving. And then ownership. Who owns all this data anyway? Is it the organization that invested in collecting it, or is it we, the individuals with whom the data has been taken? And finally, something that I'll call dataism, if you will. It's the idea that big data is somewhat of a black box. It's an algorithm which we might not be able to see inside and have the same transparency and accountability that we expect from other technologies. And it's important to understand that the data is only a simulacrum of reality. It's not the real thing, in the same way that a map is not territory. And so while we need to embrace big data, we also need to understand its limitations and be sure that we don't leave our common sense or divorce ourselves of our reasonability and proportion and discretion and our instinct and our sense of justice and fairness. There's implications for jobs. As you can see, if you're a pathologist, you might really want to wonder whether you're going to still be employed in 20 years' time. Just as the assembly line and automation threatened blue-collar labor in the 20th century, big data is going to threaten white-collar knowledge workers in the 21st century. And then there's regulation. The United States just on Thursday released a report in which they talked about big data and privacy, and in it there was a sentence buried in a 75-page report. Around page 60, they said that big data applications create social and economic value on a scale that collectively is of strategic importance for the nation. They're basically saying that this is a serious matter for economic security and America's self-interest. But the history of regulation of technology is not always a good one. This is going to be a little bit too small for you to see, but this is the actual customs form that was filled out by Neil Armstrong and the other members of the Apollo 11 space capsule when they returned to Earth, in which they had to disclose what they were bringing into the country, specifically moon dust, moon rocks, samples, lunar samples, to show that, in fact, in the world of technology and in the world of regulation, there's always a mismatch, and there's a delay in which there's a transition period in which rules from one era apply to another. And you can imagine at the dawn of the space age, people are thinking, maybe this custom form isn't the right way of dealing with space travel. So too, we're looking at many of the rules that we have over privacy and over other areas of life and saying it actually applied for another era, but not for the world that we live in today, in a world of big data in which we get so much value from it. Finally, theory. There is a view that big data means the end of theory. We don't have to worry about why things happen at all. We just let the correlations solve it for itself. But I don't think that's true. That in fact, theory is riddled throughout it. We might not need the same hypotheses, but we certainly can actually try to understand the world through frameworks. What will the future be? Well, today, it takes a deliberate effort to measure something. Tomorrow, everything is going to be quantified, everything will be measured, and it will take a deliberate effort not to measure something. It'll be interesting to see how it happens. Thanks a lot.
Really good talk, Ben.
Thanks.
Bon, on est là, donc on veut des questions. Est-ce que vous en avez? Commencez, peut-être. Moi, je vais commencer parce que c'est plus, ça va déclencher. Ken, I was hoping you were going to get to the risks of big data, and you got to it at the end.
Yeah.
How would you compare the attitude towards big data or data innovation, which may be a more neutral term, in Europe and America?
Okay, great question. And we could have had just a conversation about that. There's a difference between, I think, the public in America and in Europe and the policymakers in America and Europe. I think the public are concerned about invasions. Well, we've known this for a while. There's been a bit of a cliche in terms of the way that Europe and America thinks about privacy. In America, we regulate against invasions of privacy from the commercial sector, and in Europe, we regulate privacy from invasions of privacy with the fear of the government. And the reason why is because of our histories, right? Obviously, in Europe, the history of World War II is a very tragic one of the misuse of data in which it allowed the invading Nazis to know exactly where the Jews were so that they could actually round them up. In America, where we have a system that is so distorted in favor of business, it seems to many Americans that data brokers and credit unions are using data in ways that they're not comfortable with. Both the publics in America and Europe are uneasy with the big data world. I think that's fair to say. Neither country or region feels that privacy rules today are adequate safeguards. So in a weird way, we're starting from a good base with which to build, because everyone, if there's any consensus, it's that the existing framework doesn't work. The difference is in how the policymakers are looking at the framework. So in Europe, I believe they're taking far too heavy-handed an approach, because they're taking what already doesn't work, and they're just trying to do more of it. I think it's actually, it's like a mental disease, because if it hasn't been working for 30 years, why would you continue doing what doesn't work? I think the American policymakers have a much wiser course of action in which they say, we don't know what to do, but we do know that there's these benefits that we don't want to stop, but we do know we want to regulate as well, and the issue's not ripe enough. So we just want to exert our domain and say, we are going to regulate, but we don't know what we're going to do today.
We're going to watch it.
We're going to watch it
more
yeah.
and hear that.
Yeah. And they watch it with muscle, though. That's the other interesting thing. Yeah.
Guess, oui? Non, Pierre? Non, tu n'avais pas. Oui, j'ai vu une main là-haut. Je dois continuer avec les questions, moi?
Yeah. I'm going to get water while you do that.
Okay,
you can find a question or you can ask it.
Oui, vous avez une question? Elle va venir.
Yes. Et en fait, aussi, vous pouvez parler français si vous êtes plus confortable, parce que je peux comprendre le français.
Ou je vais le traduire.
Oui, merci. Superbe.
You talked about the lot of interest to find new patterns inside that amount of data and even to do some predictions. But once you have those predictions and those patterns, you need to act on them. And there, do you think that our future will be decided by what we've done in the past if we just look at data and no more gut feeling?
Well, I think it's a good question. I think there's lots of areas in which where our gut feeling is wrong, and so the data will tell us that. But I think there's also going to be huge domains in which we need to rely on our gut feeling, even if it's wrong, because it's the source of innovation, it's the source of risk-taking, it's the source of defying the data, because the data, in some ways, is going to be more accurate, but in other ways would not. So let me give you an example. So if you wanted to know how to recommend a book to 300 million people, right? Hard problem. The way Amazon does it is excellent. If it gets it wrong sometimes, that's fine, but they often get it right, and about 1/3 of their income comes from the recommendation system that they have, right? So in there, it makes sense to actually, it's, if you will, a simplistic problem because it's a bounded problem. You're not trying to design a new drug or think about the future in a humanistic and grandiose way. You're just simply trying to recommend a book. So in that, if you will, game, as economists call it, this sort of bounded system, it's fine to just go to the past in purchasing behavior and then put those recommendations. You lose something. You lose serendipity. You lose chance, right? And that's some of the most beautiful things that we have of bookstores today, that you walk in for one thing and you leave with 2 other things you never expected, and it changes your life. So we might want to build in serendipity into our systems, okay? But you can think of other cases in which you would want to not use data whatsoever. So Steve Jobs, before he launched the iPad, was asked by a New York Times reporter, how much market research did you do before you launched the iPad? And Jobs turned to him and said, I didn't do any market research. It's not the customer's job to know what to want. Okay. And that actually is an echo of another American famous industrialist, Henry Ford, who very famously said, if I had asked my customers what they would have wanted, they would have said a faster horse. Ford is the head of Model T Ford and the Ford Motor Company. So there's going to be cases in which applying data, even if we're just simply regurgitating the past, is fine, and we live with the shortcoming. And there'll be cases where actually the greatness of human beings and human civilization and progress is actually saying, I could turn to data, but I'm not going to turn to data. I'm going to stand, and I'm going to potentially fall on my own instinct and judgment. And I think that's going to be the most beautiful and glorious things that people will do.
Thanks.
Oui. Là-haut. It's true, Ken, that I could then not know that I was going to look for your book if it was always predicted, because I haven't read a lot about this, and then I would have missed out, right?
It's a very serious problem. I recognize, as they say, the Lord giveth, the Lord taketh away. Technology has its 2 sides of the same coin. Yeah.
Okay.
So my question is related with the exponential increase of the data in itself. So from my former lecture of science in the past, I remember that, okay, every time that something went apparently exponential forever and forever, at the end there is something changes and there is something stopping it. So according to you, what will stop this exponential increase of the data? Will it be at the end the storage of it, the way we process it, or something else that at some point will stop this increase?
So it's a good question. So there's a few. So paper has been increasing now, right, since the Chinese invented it. So you have millennia, probably about 3 millennia of the increase of paper. So it's not sure that all systems don't continue to scale. Human being and human population has yet to actually decrease, right? I mean, even during the plague, we still had population growth. Although we do know that the population will stop, right? We do know it's going to be in this century in about, I don't know, about 40 years. And then population replacement rate, well, you know the math, and it'll still grow, but then it'll start to go down in about 100 years. Okay. So what could stop it? Well, the first is a technical limitation in which we could still grow the amount of digital information, but the ability for us to have the doubling that we've had every 2 years relies on a lot of science that we're really pressed up against it. And unless we can see breakthroughs that we can't imagine today, many people have basically agreed that Moore's law is ending this year. Moore's law was framed by someone who, a guy named Gordon Moore, who created the company Intel, one of the co-founders, and he predicted in about 1968 in a very small little article that he just plotted out the number of transistors over time and said that about every 2.5 years, the number of transistors on a processor doubles. And he says, well, if you make projections, this is where it's going to go. And it hewed to that prediction, now called Moore's law, for about 40 years, right? So 30 years. So that's pretty good. But it looks now that all of the ways with which we could actually maintain that pace are exhausted unless we're prepared to pay more money than we can get selling the processor. So it ain't going to happen, right? So there, I think we'll still see growth in the amount of data, but we might not see the same level of growth that we've seen in the past. What would then be the factors that stop it? I think it's the very human nature factors of either a financial crisis, a war, global warming, these sort of cataclysmic problems that really change the priorities of civilization because we have to face bigger issues rather than buying more smartphones on a regular cycle. But barring that, I don't see actually anything changing. And if anything, many of the problems that we see today, the solution will be the effective use of data. So I actually believe that we're going to see that growth continue.
You know, Ken, as you answered, I was thinking about it because in speeches I give, or we look at Google, we see, if you compare the amount of data today to 20 years ago, and it's just the exponential, it's Moore's law still going on. And one figure that is interesting is just YouTube. 6 years ago, 16 hours of video was being put up. Then it was 32, then it was 64, and I believe it's 100 now, and I probably should. So, and with no end in sight, despite what you're saying, because I don't think it depends on the speed of the processor. If you think you have 3 billion people online now, and we're going to get 7 billion or 6 billion, the entire world sooner than we think, I think that's where you get just continuing growth. But anyhow,
Absolutely.
And you might want to give some of the figures. It's like from human history, the beginning of human history till 2002, we created X, and then every year we create 5X of data. So it really is, the figures are astounding.
Yeah.
Yes, we.
If I understood well, big data gives me insight in how something behaves. That's how it works. Now, if I want to change the course of history, what an ambition, I want to interact on it. But when I'm thinking of interacting, it's cause and effect. I want a certain effect to happen. How do I steer a system that is big data based? How do I define a policy for such a system?
Okay, but when you say you want to change the course of history, in what way would you want to change the course of history? How would you want to interact in the world that big data would impede you or help you?
Yeah, but let's say consumer behavior. They have a certain behavior. I can understand their behavior because of analysis of big data. Now I want to change that behavior. So I want to interact with the system, and as a company, for instance, I want them to buy more Pepsi.
Let me reframe it for you, because we looked at this.
Okay.
Let's say you know what hate speech leads to violence. Yep. So you could prevent the Nazis from coming to power if you could make a prediction of what type of speech led to that type of authorities. Do you think that is possible with big data?
True. Although I think that the idea of selling soda water is also a viable one as well. Let me first handle that and then take this, because you're making a presumption that you need to know causality with which to do things correctly because it's repeatable. You need to know why people are doing things, because if you didn't know why they did it, how do you know that your intervention would be correct? Well, you could know your intervention is correct in given the particular parameters of that time. What you would lose is you couldn't actually extend it beyond those parameters. That, of course, is what a generalized theory would allow you to do, a theory that embeds causality, right? You would know, for example, if I take an aspirin, I will not have my headache, right? Does everyone agree that if I take aspirin, I will not have a headache? Largely agreed, consensus? Good, because if anyone's a doctor here, you know that I've sort of set you up. That one of the greatest mysteries in medicine is that we have absolutely no idea why aspirin works. We just simply know it works. It's a correlation, okay? And I've spoken to, in writing the book, great statisticians, and I said, how can you tell me that this is all correlation and that there's no causality? And a beautiful woman, just a beautiful intellect of a woman, basically said, Ken, we have, look how causality has changed, how correlations have changed the world. We have brought men to the moon and back on correlations alone. But there's mysteries all throughout it on why we were doing things and why it worked. We just know it did work because we saw it link up. So I think that in selling soda water, right, like in the case of let's take the case
Pop-Tarts.
of Pop-Tarts, yeah. Like, why do Pop-Tart sales increase prior to storms? I mean, the answer is absolutely obvious. It's for the kids to mollify them when the power goes out, right? So no internet, no television. Here, have a Pop-Tart. No, I just made that up. Of course I did. Maybe the people who bought it don't have kids. Oh, they were putting it in their trunk because if they're stuck on the side of the road, it's like a military meal ready to eat, right? It doesn't need to be refrigerated, it doesn't need to be heated, you can eat it and you're fine. Well, I just made that up too. We could spin all these scenarios, and in fact, the more that you think about it, the more that you realize that most of the things that we do in life are complete narrative tales that we tell each other to make what is something that is incomprehensible slightly more comprehensible. And Daniel Kahneman, the Nobel Prize winning, well, he won the Nobel Prize in economics, but he's a social psychologist, basically won his Nobel Prize on basically saying that human beings are hardwired to see causality where it doesn't exist. Okay? And if you think that we have to privilege causality, I would simply turn the question back to you and say, what medical practices do we do today that in 50 years we're going to think are ridiculous and are the exact opposite of what should be done? And we'll all agree that maybe about 10% of the medical interventions we do today are actually going to be overturned within 30 years to find out that they actually are killing people or hurting people. Right? This is the history of medicine, right? So for me, I sort of embrace this idea that world is complex, our own mental cognitive limitations can never possibly know everything. When we think we have causality, we don't really have it, or we only have a small portion of it and not the whole thing in its entirety. So often, not always, but often, just having the correlations are a rough and ready way of interacting with the world. Okay, so what would we do if we could actually, I mean, this is a great question, particularly now because in Europe there is the rise of a lot of far-right parties, right? And we may have to ask ourselves as a society if we could actually find that we could block noxious information that we as society can agree spews hate from infecting the minds of young children, that we might have a better society, even if we have liberal values in which we want free flowing of information a la Voltaire. It's a great question. I don't know what the answer is. What I do know for certain is that we need to have a societal debate over that. Right? I think we need to know what the stakes are. It's very appealing to restrict information in that way, but I'm a journalist because I believe in the free flow of information, so I lay my cards down with hoping that better information crowds out worse information.
Yeah, I agree. Any other questions? Final thoughts for Ken?
Yeah.
Do you think that big data good behavior, good usage, could improve the democracy in the world, could improve avoiding wars or other things like that, positive behavior of humankind?
It's a good question. So might big data, lead to more democracy, avoid wars? I've got sort of two responses to that. The first is that it's always very appealing at the outset of a technology to endow it with these great powers that will resolve problems that we've had for a long time. And we thought with the telegraph, and we thought with even television and the radio, that it was going to lead to world peace. Now, I know that's not what you're saying, but you can see...
We thought with the internet, too.
Well,
the Arab Spring
exactly,
and
with the
so
internet,
forth.
and even earlier, exactly. But with the internet, it was going to lead to these host of solutions to these thorny problems in society. And of course, that's just not the case. In some cases, it perpetuates problems. In other ways, it creates new problems, but it doesn't actually do all that we want it to do. That's sort of my first embrace. So do I think big data is going to do these things that we would like it to do? Absolutely not. Or if it does, it'll do things well, but it's not going to be the solution. But I think but you're putting your finger on a tougher problem in which don't want to leave you in a depressed state. But actually, if you think about what I've been saying and how politics is done where big data has been used, in the case of the United States, what you can see is that actually it leads to a whole host of new problems that are a bit frightening. Let's think about this. So both campaigns have databases that include N equals all the data. That is to say, every single voter, whether who they are, whether they're likely to vote or not, because you don't want to send promotional literature to someone who's not even going to go to a poll, and if they're persuadable or not, right? And of course, it's really about battleground states that you care about, because America is so politically divided that it's really only about 15 counties in the whole country that actually really call an election either one way or another. Fine. So by doing this, the campaigns collect vast amounts of data about people. So first, there's a privacy interest. It's kind of spooky. Can you imagine if Hitler was trying to win an election and was using big data to do that? We'd have a very different outcome, right, of how society would be governed. But then think about this. Obama, right now, in 2014, is sitting on one of the most prized assets in the entire world, data on what preferences individual voters have. So who's he going to give it to in 2 years? Joe Biden or Hillary Clinton? So right now, he's the kingmaker. And it could potentially perpetuate, not in America, but in all democracies, right? It could perpetuate a sort of elderly, incumbent, rich culture of politics. And that's amazing to say in America, because we know that in 92 and 94, if you were to ask who was going to become the next president, it certainly wouldn't be a governor from Arkansas, Bill Clinton. And we do know that in 2008, if you were, 2007, who was going to be the torchbearer for the Democrats? It was Hillary, and not an unknown junior senator from Illinois. So it's extremely important for politics everywhere. And we've seen cases, particularly in France, where when you have a political culture that simply embeds the status quo and the established politicians and perpetuates them, there's no renewal, right? There's no refreshment that actually democracy needs in order to have new ideas filter in. In America, luckily, the only good thing about going on in politics in America is that we have a presidential system that we can sometimes get new ideas in, people like Obama. But we potentially lose that when the data becomes so valuable and the barriers to entry, because amassing it, is so vast. So if anything, I am nervous that unless wise people see a solution to this problem, we're going to see politics not become more responsive to people, but if we thought they spoke with a forked tongue or a Janus head, good luck with that. you can imagine that now, instead of having different messages based on different states or categories, we might have in America 300 million messages tailored exactly to that person, and we don't know what a candidate believes, but we do know it's being perpetuated by a party system that is very hierarchical, more than ever before.
Well, maybe that's a good way to end, because Belgium is facing its own elections, and I don't know how much big data is being used in the upcoming Belgian elections to determine, but I think you'll need big data to decipher the results. So we'll see. They're complicated more than. Donc, merci pour être venu. J'espère que ça vous a donné un petit goût de ce qu'on va essayer de continuer pendant l'année capitale de la culture entre Google et Mondeneum. On va travailler ensemble pour amener les gens comme Ken qui peuvent discuter ces sujets avec l'humeur, humor and fun and anecdotes. Donc, merci encore. Il y a pour tout le monde un petit boisson, quelque chose pour fêter après, et on va rester avec vous pour discuter dans un cadre informel. Merci encore, Ben.
Thanks a lot.